Okay, it's in the chat. You can use this link. Like you can keep this handy. Tirisha, sorry, you will have to make me co-host again and Anusha co-host. Hey, Tirisha, can you hear me?
Hi, Vaidegi.
Yeah, you'll have to make me and Anusha co-host. And Anusha, are you feeling better now? I just saw the message. You are high in fever. Are you feeling better now?
Ma'am, I'm feeling better. It's
Like,
okay now.
that's okay. You can ask Siddhi to join instead of you. That's all right.
Yeah,
You
it's
know.
fine. It's just like traveling at the morning, I thought make it more worse. Yes, I'm
Uh,
fine. That's why I told that I will just do it online.
okay. So yeah, then it's okay. So thank you so much.
Yes,
And
ma'am. And the message you shared is a live stream link, right, ma'am?
yeah, it's a live stream link. Keep it handy. Don't share it now. Like yesterday, we'll see
Yeah,
like
yeah, yeah.
500.
After 800 to 900 participants, we will share it at the groups.
Yes.
Okay, ma'am.
Okay.
Hey guys, very good morning. Let's wait for 5 more minutes. Let's like other students also join and we'll go with the session.
Hello. ఓ- ఇది ఉబుంటో ఏ ఫార్మాట్లో డౌన్లోడ్ అయింది?
Hi everybody. Can we please mute? Trisha, I think we can mute everybody till we start the meeting.
Yes. Hello everybody. Like it's very happy to see like good number of participants today. So welcome everybody for the event today. And so yeah, we are all here for Datathon, IBM Z Datathon, which is hosted. Before we start, so we have like this is the agenda for today's event. So we will start with intro to Shooting Stars Foundation, IBM Z Datathon, and Datathon events. And we'll also meet IBM Z SMEs and also SSF volunteers. We'll have a session with keynote speakers and we'll let you know the participant to-do list, and then we'll go with the datathon and we'll begin with your event. And now I request
Trisha,
Is it me or there's
Lata,
some internet issue?
our
Trisha,
CEO and the founder of Shooting Foundation, to take the session on and introduce the Shooting Stars Foundation now. Lata, please, please.
okay. Thank you,
Yes.
Trisha. I think there were some bandwidth issues out there. So hi everybody.
I
Let's see. Yep. Are you able to hear me, Sudarshana? Yes. Okay, good. Hi, I don't know, is it good evening, good morning, good night in certain parts of the world? Welcome, welcome, welcome. My name is Lata Narayanan. By day, I'm Associate Vice President of a cybersecurity company here in San Jose, California. And by night, I volunteer and manage Shooting Stars Foundation. So welcome everybody. I see about 200 people in the call. I guess we were expecting 1,000 people. Hopefully people are starting to join. But welcome everybody. Shooting Stars and IBM have been partnered together for the past 4 years. This is the fifth year of partnership. And we are presenting to you this IBM Z Datathon. Shooting Stars Foundation is a nonprofit foundation registered both in US and in India, and our mission is STEM empowerment. We strongly believe that STEM education will change the financial trajectory of anybody's lives, and this hackathon is a huge part of STEM that inspires, instigates your curious minds to get to the next level in STEM education. We can go to the next slide, please. Trisha. Next slide, please. Can you hear me, Trisha? Yep, there you go. Okay, so again, we do operate in different parts of. Oh, one behind, please. The world map slide, please, Trisha. I think it's slow, probably in Trisha's, and it is slow. Yes. So as I said, we do everything about STEM. Till date, we have run more than 100 plus programs, and we have about 40,000 plus students that participate in our programs. Again, our entire goal is by giving access to these kind of STEM programs, we instigate the curiosity in the minds of students, both middle school, high school, and college, to get to the next level of taking a STEM major or STEM career and progressing in their STEM career. So these are some numbers, that we kind of deal with. Next slide, please, Trisha. Yes, there is a lag, Trisha, from the time
Yeah,
you.
so actually she is at one of the campuses, GAT campus, and they're in the auditorium because everybody is there. There seems to be some lag.
Okay, there you go. Okay, so again, as I said, Shooting Stars work with different corporates throughout the year to get these programs to you all. And IBM is a huge partner for Shooting Stars. Just for the fact that we have been doing this for the fifth year shows our collaboration between IBM and Shooting Stars. The goal for this IBM Z Datathon is to promote the Z technology, right? I'm pretty sure there are going to be keynote speakers who are going to talk about the IBM technology. But for me, I've always thought IBM has been mainframe, right? But this is going to open your eyes to really say, hey, IBM is in the forefront of these technologies. You're going to see a lot of data platforms. You're going to see a lot of AI platforms. I mean, IBM is a very different version what you'll be seeing today and working on. For the past 4 years, and this is the fifth year, past 4 years, we've been working diligently. 2022, we just had a couple of colleges in India that we worked with and online. 2023, we expanded worldwide. I was there in London in 2023. We had Savita, a number of you are from Savita Engineering, SRM, and Global Academy, right? So that's where we did in 2023. And last year, of course, we expanded a little bit more to South Africa and Mainz, which we're again doing now. So in 2025, again, all of the locations that you see there is being held. So we do both online and in person. So, we've reached about 11,000 registrations online. Very, very happy to see the growth. Just because, and I know many of you are also repeat audiences that come in and take advantage of what IBM Z has to give. Again, me being in the technology line for the past 30 years, I've been in cybersecurity and other technical thing. IBM is a huge name. You all know IBM is a huge name. It will really, really be helpful when you create these projects in the IBM platform. Show it in your resumes. and especially the winners are going to get to execute and complete their projects with the IBM mentors. That's going to be a huge value add to your resumes when you go out and look for a job. So, and you're going to hear from a lot of these winners, a lot of the IBM Z ambassadors who come back and carve their future using the IBM technology. So again, here's to you. Good luck. Really, really happy with the turnout. And we're all very, very excited to see what you could produce as your projects. Good luck to you all.
Thank you so much, Lata.
Okay.
Thank you
move
so
on.
much, Lata. That was a great insight on SSF for the students.
Yeah, Trisha, maybe we can move to the next slide. I will take this.
I think there's definitely a lag there.
Yeah.
Should somebody else share?
Yeah, let me
Can I?
present the screen.
Yeah. Okay, there you go.
So with it, again, welcome everyone. You had an introduction about Shooting Stars Foundation. Now we'll move into the IBMZ Datathon, for which everybody are here. You have been here for, some of you have been here for the beginning when we started the registration, when we started outreach. You even helped us reach out many colleges. We had a target of 11,000 and you guys made us reach to 15K mark today. So today you guys are working with 15,000 students and there's going to be no winner. I know we always project it on a screen that there is a global prize. We have first winner, second winner, third winner. But if you are participating among 15,000 students and you're submitting a project, that's an achievement you can definitely show. Even if you show up participant certificate that you participated in a datathon which had 15,000 students, that's an achievement for you. So I will encourage, do not get dismotivated or demotivated. Make sure you're working on your project. You have all the links. You had an amazing session yesterday on the Linux One system readiness, and I already see students working on their projects. So make use of it. Make sure you are at least submitting your project, doing your best without thinking about whether it will be a winning project or not. With that, as you already know, there are multiple locations here, so that's another feather to add. There are students participating virtually. Then you have global participations from Imperial College. There is participation from TUT College in South Africa. And there is participation from Mainz University in Germany. So that's another thing you can, of course, show that you have participation from global students. And among them, you guys were able to submit your projects. With that, as you can see, uh, not just by the number, by the countries also. While I mentioned we have in-person participation in London, Germany, and South Africa, you will see total 44 countries from where we got the registrations. So we will get you all these stats so that you can reflect it on your CV. I know all these matters. These numbers, when you bold it in your resume, that will definitely add another point in your resume. You'll definitely get some more pointers whenever you flash your resume, whenever you reach out to your interviewers. And for this session, you already are there in the Discord channel. You will see there are two different channels. We have IBM Z SMEs also, who will help you in all the technical uh, clarifications you'll be needing, any issues that you'll be facing with this system. You have about 25 plus SMEs. Apart from that, you have SSF volunteers also who can help you with any operational related issues as well, which is like you're not able to access any platform, you are not able to submit your projects, you are not able to work with a team member, another one of the team leader is not able to submit, you need some other team members, those kind of questions. So please be very careful. For you don't have to tag anybody, we are all there. As soon as you will raise your query, we will read it and will respond to it. And for this datathon, we made sure you had multiple sessions. There were multiple sessions that we organized for you guys. All the recordings were already shared with you. Any issue that you have with regards to how to make a project or what sort of idea you should pick in, all these recordings will be there in the guideline. That's why we had these 7 7 pre-event sessions. Those recording will be available to you guys so that you can look at those recordings whenever you have any doubts. With that, I'll just quickly introduce the SIP team. You only see 3 of us here, but there are amazing team members, Lata, Vaidehi, myself, and Tirisha. And apart from us, we have Deepthi, Anusha, and Siddhi. Deepthi has been the marketing lead for us. She helped us doing all the outreach. Anusha and Siddhi have been the amazing support. They were the backbones. They made us look good among all the students in front of all of you. They were doing all the hard work in the background, all the Excel sheet. When any student came up with teaming issue, these were the guys who were handling it. So thank you to all the team members. I know they are not here, but of course they will know we are appreciating them. So these are few sessions just to give you a quick brush so that you know what we're talking about. In case you want to go into the recording, you can see you have a session on how to win Datathon, which was taken up by Rukshana. You'll be able to see the recording of it. And you will also have winners from last year talking about their experiences in these sessions. So I would encourage any doubt, go and see these recordings. I'm sure you must have already seen it. The second session is ideation session, which was taken by Vaidehi Peter. This was the same pattern. While she shared while she shared or talked about some of the pointers on how to create an idea, you must have recording for this as well. Then we had some IBM SME sessions also. These were specific to some campuses. We had the recordings as well. We have shared these recordings as well with the students where the IBM Z SMEs, they came up, they talked about what IBM Z Datathon is, what are the relevant skills that you may be needed, what are the career pathways through IBM Z. So not for now, but of course you can definitely listen to these recordings as well. This was the biggest session. All the recordings are there in your in your WhatsApp group, in your Discord group. You'll be able to see all these, you'll be able to see this recording as well. I know many of you are already raising questions with not being able to access the Linux One system. I would recommend go through those recordings and do not raise these questions again and again because the answer is going to be same. We are just going to repeat the same response that we repeated last time. So make sure you're seeing the recording. You're seeing all the links shared. There were some important links, like 2, 3 links, which were shared yesterday. Look at the announcement channel. You will see all the links there. With that, just kudos to all the IBM Z SMEs. You will see their names on the screen. I would recommend don't tag them, but yes, you can definitely recall these names. That these will be the guy who will be responding to you. In case of anything, you will see response coming from them, and then of course you can see, you will see this is an authentic response. Nobody is spamming you. So make sure that do not tag them, but keep these name with yourself. So that you can see that who is responding to you and they are not another student, just random student playing along. Some of the SSF volunteers here, I know we have a huge list here. While we have this hackathon, Datathon 24 hours, you won't see them available throughout the 24 hours. That's why we have number of volunteers and SMEs, so that some of them will be allotted in some of these slots. So, but your queries will be addressed during this 24 hours in between these slots. That's rest assured. With that, I would welcome our keynote speakers. We have Amit Singhi and Ambayakan Mani with us. I will also hand it over to Sudarshana, who is the IBM organizer person with us. Sudarshana, over to you if you would like to welcome our keynote speakers.
Excellent. Awesome. Thank you, Lata, Vaidehi, Trisha, and the rest of the Shooting Stars team for pulling this IBM Z Datathon event together yet again, 5 years and counting. As Lata said, I think it's a milestone for us all to celebrate for sure. With that, my name is Sudarshana Srinivasan. I work for IBM as a senior firmware development manager. It's been an amazing journey and ride, working on IBM Z Datathon all these years with the Shooting Stars team. I wholeheartedly, resonate with your sentiment, Lata, that this has been quite an amazing collaboration between IBM and Shooting Stars Foundation. Year over year, we've grown leaps and bounds exponentially, and it's just been amazing to see. I think the most fulfilling aspect about this event has been the truly innovative, creative solutions the student teams have created. I want to say, I think, Vaidehi, I saw a stat that you put out there. Over the 5 years, I think we've had 300 or 500 plus entries or submissions, unique ideas being shared by the students. So we're looking to break that record here this year with, just this event alone bringing us about 400, 500 entries. So like Vaidehi was saying, right, just stay with it. You have all of the resources available. We've put in a lot of time and effort to make sure that you have, access to the technology stack. You have documentation to help you how to get to it. A video walkthrough that's out on YouTube. Shooting Stars has done a phenomenal job making sure all of this is shared with you on the Discord channel and it's pinned over there. So take the time as you get started here today to review all of this content as they are very useful guides, right? And with that, I will just say it's a pleasure to be here today and to kick off IBM Z Datathon 2025. And a huge kudos and thank you to Anbaragan Mani and Amit Singhi. They have been, very generous with their time. I want to recognize that this is a Saturday, right? Friday night and Saturday morning around the world, and it's the weekend. So, thank you to everyone for taking that extra time. So thank you, Anbu. Thank you, Amit. Without further ado, Anbu, I think you're here on the call. So if you are able to kick us off with AI and IBM Z, that would be great.
Thank you, Sudeshna. Thank you, Shooting Stars team. Let me share my screen. Are you able to see my screen?
Yes, we can. Do you want to go into screen share slideshow mode? Yeah, there you go. Thank you.
Thank you. Good morning, everyone, and good evening for the people in the US time zone. Good morning to all the people in India. So my name is Anbu Mani, and thank you, Sudeshna, for the introduction. So one of the distinguished engineers for IBM Z and Linux One development, based here in Bangalore, India. And really excited to talk to you about what IBM Z is and what we are doing and what's the new generation of IBM Z is bringing to the customers, and how you can participate and how you can be part of this large movement that's pretty much running the world economy. So with that, we'll get started. A quick quiz on what's happening in 1 second, right? A lot of things that happens in 1 second. If you look at Instagram, I know a lot of you are on Instagram, posting and sharing your stories. So you can see that, was there a question?
No, sorry, request everyone to be on mute, please. You can
Yes.
go ahead.
Thank you. So there are about 1,200 Instagram posts per every second, and if you look at other social media like X, there are about 10,000 tweets coming in, X posts coming in per second, and then Google searches over 100K Google searches per second, YouTube videos, right? Many of you watch the videos, right? And LinkedIn. So you can see, right, what's happening in the social media. And then when we come to IBM Z on the mainframe, we are seeing over 1 million transactions per second. And this system has evolved over a period of time to be able to handle a high volume of transactions. And what does it means to all the industries, right? Every time you use a credit card for making a transaction, buying your favorite things, online shopping, it goes through the mainframe. Every time you reserve an airline ticket, it goes to the mainframe, right? Insurance, same thing, right? Every time you buy an insurance policy, it goes to the mainframe. Telecom, 8 out of 10 telecom companies run on the mainframe. retail, your favorite retailers. So you see banks, insurance companies, airlines, all the things that we use on a day-to-day basis, pretty much it all runs on mainframe. The net effect of it is what we call as, 70% of more than 70% of world's transaction by value runs on the mainframe, right? And that's a big thing. And that's what I mean by running pretty much the world economy. If more than 70% of transactions are running on mainframe and IBM Z, that's powering the world's economy. And why should it run on mainframe, right? Come think of it. This technology has been evolving for a very long period of time, and more than 70% of transactions is because of all the things that mainframe brings to the business, right? What does Z in IBM Z mean? It pretty much means zero downtime, right? The system can never go down because it runs all those mission critical workloads. So the system never goes down, and we'll talk about what technology is behind powering all of this. It can consolidate a massive amount of workloads. It needs fewer cores, 16 times fewer cores than compared to the commodity processor architecture. Because it's able to consolidate all the workloads, because it's able to virtualize the workloads, because it's able to do more. It's able to do save a lot of energy consumption, right? You can see 850 metric tons of carbon emissions saved annually by running these mission critical workloads on the mainframe. And all of this, it needs less power, less cooling, less administration cost. So this is where it is helping, not only having the reliability and zero downtime and scalability and performance, but also helps in sustainability by reducing the carbon emissions and the carbon footprint that is required today. And what's the magic behind all of this, right? If you look at like public cloud, the system could be made from various vendors. Like the processor could be from one of the vendors, the IO subsystem can be from one of the vendors, the GPU can be from one of the vendors. But we call IBM Z or the mainframe as the total system because the entire thing is built by IBM and it's integrated to provide the experience and the reliability and the scalability and performance that we spoke about. So it is a fully integrated stack that brings a lot of technologies together, right? When you're talking about zero downtime, what makes it right? Zero downtime. There are technologies like parallel sysplex and coupling facility that allows multiple systems to come together and behave as a single system, high speed communication and data sharing, and that's what brings zero downtime because there is no single point of failure. And this is from the all the way from the hardware to the firmware and to the system is there is always redundancy built into the system, disaster recovery and high availability, and the concept of logical partitions that enables each logical partition to behave like an independent system, completely isolated from other LPARs or logical partitions, right? And there is redundant memory, and there is virtual cache hierarchy. There are a lot of things that happens architected into the system, to securely run and scale transactions for the business. And the system was introduced, right, where, in System 360 was introduced in the year 1964, and it's been evolving, more than 60 years now, right? And you can see the advancements, right? From System 360, able to handle, 35K instructions to all the way now, millions of instructions per second is what we call as MIPS, and, tremendous increase in memory and clock speed. So that's an enhancement. Virtualization was introduced in the system long back. The concept of logical partitions, workload management, on-chip compression, right? Encryption, crypto acceleration. So there has been several enhancements to the system, and then most recently I'll also talk about AI acceleration in the upcoming charts, right? That's where it is. Whatever the workload needs, the system is able to integrate and provide it to do to kind of run the workloads in a much better way. What's your favorite car? I know a lot of you have favorite cars, right? It spoke about the year 1964 introduction of System 360. Porsche, right? 911 was introduced in 1964. Just a fun fact, right? And then, it's been evolving since that year until this year. And you can see the advancements in the top speed and, 0 to 60, how quickly it can accelerate and all of it, right? And you can see, right, and compare mainframe with Porsche and, how it has evolved, over the last 60 years and advancements that is happening over the system. Right, we spoke about security and reliability and scalability and performance, but there is another big aspect that is very important, which is the concept of security, right? And security is very important because, when you're running transactions, it's the most important thing, right? You need to secure your transactions, to allow bad actors from not getting into that. And the mainframes have always been in the forefront of security, right? Whether it's pervasive encryption, encrypting all the data, right? And we spoke to the many of the customers, several years back, and they were not encrypting all the data, right? They were only encrypting 10%, 15% of the data, and that's when we introduced pervasive encryption to encrypt 100% of your data without sacrificing the performance. And then most recently, right, with the advent of quantum computers, the classical cryptography is, there is research already that proves that classical cryptography can be broken by, Grover's algorithm, by, new algorithms that can break both the symmetric key encryption and asymmetric encryption. And that's where, we already introduced in Z15 and Z16 and enhancing in Z17 is the quantum safe encryption or post-quantum cryptography. These cryptography algorithms are quantum resistant, and to be able to identify the weak ciphers and weak cryptography algorithms and able to move to new quantum safe encryption and the new algorithms that we support, working with the industry partners and industry organizations like NIST to standardize these algorithms. So net, what does it mean, right? It means we have a huge amount of transactions and they are running on the mainframe systems. You have security, performance, scalability, and zero downtime. And what's the new thing that's happening in the industry now, right? It's a two-letter word that we read a lot about it: artificial intelligence, AI. And when you have transactions running on the system, and now you have this whole AI view, right? The wave of AI frameworks and large language models and foundation models, machine learning and deep learning, IBM Z16, and now in Z17, we have been adding new technologies to allow AI acceleration closer to where the data is. So you don't need to take your data outside. The AI is integrated into the system, into the processor itself, in both in Telum and Telum 2. We have now AI accelerator, on-chip AI accelerator that sits within the processor itself and able to do more than 450 billion inference operations per day, enabling new use cases like fraud detection, credit card fraud detection, UPI fraud detection, right? Claims processing. I'll talk about a lot of use cases, but you can see, right, the AI algorithms, the acceleration of AI algorithms is now closer to where the data is. And this allows a lot of interesting use cases, and you can see there fraud detection, right? Credit card fraud detection. You have less than a second to execute a credit card transaction, and how can you run an AI model, right? We can do that with Telum and Telum 2. And there are several other use cases like claims fraud detection, anti-money laundering, right? Insurance, claim processing. Many use cases in the healthcare domain, in banking and in insurance and financial domain. And agentic is coming to the system, right, into the mainframe system. Agentic AI. We just announced Spire in Tech Exchange in Orlando. You can read about it online. Spire is going to be, it's not part of the processor. It's not an on-chip acceleration. It sits in the I/O drawer. Amit will talk more about it, but Spire provides an ability. It's on PC attached. It provides an ability to run foundation models and large language models for your mainframe workloads. But you get the idea, right? I mean, so we have tremendous innovation happening on the platform with the introduction of a lot of these technologies, including AI. So what does it mean to you, right? There is, we have been seeing several industry surveys, mainframe surveys that talks about, the staff and the workforce, right? The current mainframe teams are understaffed and aging, and there is need for more IBM Z skills, mainframe skills, and that's where you all can make a big difference. Like IT leaders are finding difficulty to find new hires, and you, when you are coming to the workforce, have a unique opportunity to take this modern technology, the modern mainframe, right, with all the things that we talk about, to be entering into the workforce and then shaping your career by having Z skills. And when you talk about Z skills, right, you can see in this chart, it's not very different from what you already learn in your college, right? Yes, there are many unique, mainframe technologies like COBOL. By the way, you can use AI to understand COBOL and refactor COBOL and modernize COBOL, right? And JCL. But there is also like support for Python, to support for Java, the support for Linux, Golang, right? You can use databases like Postgres, MongoDB, right? You can use all your AI framework, whether it's TensorFlow, PyTorch, right? And this is not very different from what you are doing in college and all the projects that you are doing. So you can bring your technologies, your innovations to the platform, to the mainframe platform, and build on top of it, right? Today we are adopting a lot of modern technologies, Linux, Kubernetes, Docker, OpenShift. You can read the list, right? But you got the idea, right? It's not about legacy, but it's about bringing innovation to the platform and modernizing the platform with all these technologies. So with all that, you can ask the question, right? How can I get started, right? How can I learn this, right? I have some good news for you, right? We have many programs like IBM Z Explore. These are completely free, and it provides a progressive learning path, right? You can start with the basics, like concepts, and then you have hands-on access to mainframe sandbox environment, Linux on mainframe environment, right? And then you get badges, right? These are like certifications, industry recognized badges that you learn as you complete these online courses in Z Explore. And end of it, you are like job ready skills that that you can add it to your resume, to your LinkedIn profile, right? And this is what unlocks new opportunities in this growing IBM Z and mainframe arena. Right, and we have other things like mainframe career depot that establishes a two-way marketplace for employers to find you, and you can find employers, and you get the idea, right? It's all about building skills, visibility, and also the landscape of companies. Leveraging the mainframe can reach out to you when they are looking for skills, and then this is where the Z Explore and the badges that I spoke about makes a big difference. In the end, I know a lot of Z student ambassadors are part of this meeting today. Thank you for being a Z student ambassador and championing the cause. And this is a program, right? If you're interested in being a Z student ambassador, right, in many countries like United States, like India, right, Canada. So there are many in Europe, right? This is a technical and leadership development program, right? You complete the Z Explore badges to be eligible for it. So you're knowledgeable, you sign up to the community, you can run events on your campus, right? If you're part of, some of the colleges and universities, right? You can establish like a campus club and you can build awareness, right? And be a champion, and you can go social media and post about what you have learned. So this is all about building technical skills, building communities, and also building leadership and get noticed, right? As a Z. And you can go to the IBM conferences and events around the world, tech exchanges. And this is what gives you, right, the kind of visibility to get noticed and build your expertise and leadership. So I certainly encourage, you to leverage this program and reach out to our IBM contacts for further help or to the Z student ambassadors in your campus. So with that, big thanks and to be part of this, really, really happy to be part of this and talk to all of you and looking forward to connect, share and learn and, provide our guidance and expertise to all of you. Thank you all.
Thanks so much, Anbu. I know, Amit, thank you for joining us as well. If you can take it away. You're on mute, Amit.
Okay, can you hear me now? Awesome. And do you see the slides I'm trying to share? Okay, great. Here we go. So, very warm welcome to everybody who's on the call, and it's a pleasure to talk to all of you about some topics that we are very excited and spending every day working hard on together with Anbu and many others in IBM. I represent the research division in IBM, particularly the team in India. And I'm going to spend a few minutes talking about what's next in AI from our lens. I think somebody has a mute button that's going off and on. Okay, here we
Yeah,
go.
I'm trying to fix it. You can continue now.
Thank you. Okay, so a little bit about, I'm sure many of you know we are going through this fascinating emergence of something called AI agents. And I just want to start with that. Looking, let's say a year ago, before AI agents started becoming mainstream, what were these AI bots looking like? They were kind of relatively simple, where the user will have a question, it gets converted to a prompt by the pipeline, and then that goes to an LLM. The LLM might use something like a retrieval augmented generation pipeline, a memory basically of knowledge, and then generate some answer, right? I'm simplifying this a bit, but the basic idea was it was a feed forward question answering type of approach to build these AI bots. Now, with agentic workflows, there's a lot more that's now possible behind the scenes. The user can actually ask more complex questions, not just questions about knowledge or how to do something, but can actually ask these AI agents to perform certain tasks on his or her behalf. Now, the AI agent takes that intent, it thinks through it, looks at all the tokens of the intent and can generate a plan with steps to try and address that intent. It can then act on that plan by calling APIs of tools, maybe running Google searches or looking at shopping website or looking inside the company on some proprietary APIs within the company, whatever is relevant. It can observe the results from those actions from the API calls. It can reflect on it. And it may regenerate the plan to say, oh, okay, the original 5 steps I was trying to do, maybe I need to add one more step after this, something like that. And it goes through this loop. And once it's has completed the task or has come up with the appropriate answers, it can generate the answer back to the user. So there's a lot more activity that is happening. The LLMs are being used for many different types of things here, for thinking, planning, acting, calling tools, observing, refining, and so on. And each of these is an inference call to an LLM with a prompt and some output that is being analyzed and so on. Right? So with that basic idea, I want to show you a little bit about what does it take to actually build and maintain these AI agent systems. These are ultimately complex software backed by these models. So in some sense, a lot of machinery is needed to make sure that they run at scale, and as we call it, at the enterprise scale. So at the top here, I'm showing you some examples of AI agents, whether they're coding agents in software engineering or for productivity in IT operations like site reliability or FinOps, or maybe in maintenance of physical assets. These are agents that can take diagnosis problems and can come up with answers for you or fix bugs in software, things like that. Now, ultimately, at the bottom, they run on hardware, some computers. And Anbu talked about the amazing IBM Z and the mainframe environment. We also have Linux one. These machines from IBM have advanced AI accelerators, the Spire accelerator coming. There's IBM Power. There's IBM Cloud, which offers a wide variety of different compute environments with different GPU options. Many clients also might prefer other on-premise data centers that they might have, especially banks and governments that have a lot of private, secure data, or their clients who might be using other clouds, right? So it's important to allow companies to run these agents on a wide variety of different hardware of their choice. And this is really what hybrid cloud is about. And that's fundamental to the way we design all of these things in the middle that I'm going to talk about. One big chunk of what happens between the agent and the hardware are these agentic middlewares and frameworks. Many of you may know about the agentic frameworks like Crew.ai, LangGraph, Model Context Protocol, things like that. These are basically, coding abstractions that let you define the wiring of that diagram I showed you. It lets you define, code up how different pieces of it are going to interact with each other. And that's very, very useful. Without that, you have to write maybe 10 times the code to make it happen. But that alone is not enough. You also need a middleware to manage this thing that you've written and to make sure that it's secure. And so the agentic middleware layer shows a few of those capabilities that are needed there. And in IBM Research, we are working to develop many of these. And over time, they become part of our products. For example, watsonx Orchestrate. One example is tool ops. These agents, they call APIs of tools. And those tools themselves are complicated pieces of software, or they may themselves be agents using AI. So they also need to be managed like any other software or IT environment. And there's a life cycle for it. And that's what tool ops is about. Another example is security, where these agents now will do a task for you. You might say, go and create an entry or a new employee entry in the HR system. So it needs to act on behalf using your identity, using your authorization. It needs to monitor and log for every action that is taken for auditability. So there's a lot of things that need to happen so that the agent behaves and integrates with the cybersecurity architecture of the company. And just writing the code in the agentic framework will not do it. You need tools that can monitor all of that. Now, below the middleware is the actual models and runtimes which execute the AI. I've shown a few different model logos here. My favorite one is the green one, which is the IBM Granite family. But of course, we allow and enable equally all these models to run on the software and hardware stack that we're developing in IBM. And clients also want to use a variety of models. They want to be able to switch models as one model gets better than the other over time. And below that are the AI runtimes. These are the software that actually runs these models, tunes these models, serves these models. So there's technology like VLLM and LLMD. These are for inferencing. That means when you throw a prompt at a model, it needs to execute that and return back with the answer and do it in the most efficient and accurate way possible. And then there's the fine-tuning stack, which allows you to take models and fine-tune them offline with proprietary data to make them really good in some specific tasks or specific domains. All of these are open source projects that we work on from IBM. And there's big communities out there that contribute to these. And then they become also part of our product stack with Red Hat and watsonx, so that they become commercially supported for our clients. And then there's this piece of generative computing, which I will get to. That's a very exciting new emerging area. Okay, let me give you some examples in each of these layers. When you look at coding agents, here's one example. We've asked ourselves, what's a good thing that a AI agent can do in the software lifecycle? And one good thing was bug fixing. Nobody likes to fix bugs. You'd rather implement new ideas. Now, to fix bugs, the AI agents need to take certain input, and the input is what? It's the code base, let's say Python code with files and folders, and the issue or the bug report, which has a description of what is the bug or what is the observation of the bug, the symptom. Now, for this, we developed two types of agents. One are these localization agents, which use a variety of different models. And what they do is they read the bug report, they look at the code base, and they identify where in the code, which parts of code are actually relevant for the bug that has been reported. So it's a localization. And you can see underneath it uses this think, act, observe workflow that I was talking about, but it uses special tools that are relevant for the localization process. For example, doing syntax-based search within the code files, or inspecting the code by opening it and passing the tokens of the code into the model and analyzing it, or running bash commands to navigate the folder hierarchy and the file structures. All of these tools are used iteratively in this think, act, observe flow to identify, okay, which are the lines or files which have code that are probably relevant to the bug. Then the next phase are these editing agents, which say, okay, I've now identified the likely areas where the problem and the fixes need to be. Now I need to think through it and actually make the code changes. That's why this is editing agents. Here too, there's a think, act, observe type of a workflow, but the tools are different. These are editing tools like an editor, like VI or Emacs or whatever your favorite editor is that you give to the agent so that it can open files and edit them. It needs checkers so that it can check that after editing, is the code still correct? For example, linters, compilers, code scanners, and then repair tools that so that when you check it and if there's an issue, how do you make it repair again, right? So we wanted to see can we push the quality and performance of this system as high as possible to make it as good as or close to as good as what you can do with some of the frontier models, which are not open models. And these are some results on the localization agent. On the right-hand side, there are these 3 bar groups, which are all based on some of the top agentic workflows using Claude Sonnet. And when we use these open models, we see we get pretty close. Not exactly there, but close enough that this is quite impressive, and it allows our clients the option of deploying these AI agents in their on-premise environments or in their secure environments rather than sending their code to the internet over the internet to some other cloud like Claude's cloud or somebody else's cloud. Going back to our stack, let's look at another example from the middleware layer, the tool ops. What does this tool ops means? Tool ops really is the tool operations or tool lifecycle management. And there are 3 kinds of things that you need to do in managing the lifecycle of tools. Somebody has made a tool. Now the tool is basically a set of APIs with some description of what the API does, so that when you give it to the LLM and say, LLM, you need to do some task, it can pick which of the tools to use for that task based on the description. So tool enrichment is about looking at the description and the metadata around the tool and seeing if it is sufficiently accurate and descriptive for the model to actually use it effectively. And I'll show you an example after this slide. Tool validation is about validating whether the tool actually does what it's supposed to do, because the tool itself can be a complicated piece of software. And testing that tool for all the right things and automating the testing process of the tool is what tool validation is about. And then tool profiling is about monitoring this tool during runtime so that once the agent is deployed, it's using the tool. Does the tool continue to behave correctly? Are there performance issues with it? Is there some unexpected behavior that happens in the field that you did not discover when you were testing? Just like any other piece of software that is deployed. Now, let me give you an example of tool enrichment. Let's say we take these 2 tools, right? Think of these as APIs from an HR system. Get payslips and get compensation. Get payslip means given a user ID, get the payslip from say last month or 2 months ago. What was the salary statement? Get compensation, however, is about what is my overall pay and my breakdown of provident fund and things like that. And in the yellow boxes, you see 2 different questions coming from the user. One is how much HRA am I getting? And the other is give me the net pay I received as comp last month. And based on the descriptions here, the model actually picks the wrong tool. However, if we make the descriptions more specific with a little bit more detail about what exactly that tool does, then in the pink box, you see that the model actually picks the correct tool for the correct question. This is why it's important, this tool enrichment step is important to make sure that you're providing the model a fully complete and accurate description of the tools. Let's look at the model layer, and here we're very excited about our new Granite 4.0 model release that just came out a week and a half ago. Just to position Granite to understand where it stands. If you compare it to some of the other models that are in the same category of the 2 to 4 billion, 5 to 8 billion, or 9 to 30 billion parameters, we have done a lot of innovations to make Granite really, really optimized and small in terms of resource consumption and memory use. This is showing you the estimated RAM required, and you can see the RAM requirements are very, very low compared to competing models. However, this still with very high quality. And this chart shows you on the y-axis, it shows a function calling benchmark, which tests how good the model is at picking the right tool and calling the right tool in the right way when you use it in an agentic workflow. And on the x-axis, it shows the hosted API price, how many US dollars you have to spend per million tokens for using that model. You can see with Granite, the small version, which is a 30 billion parameter model with only 7 billion activated parameters. It's really in this preferred operating zone where you get very high function calling accuracy, but a very low API price. And that's because we have really optimized the size of the model and its inferencing cost. Another very important step in the agentic workflow is doing retrieval augmented generation. And there also, when you compare some of our Granite 4.0 models with competing models, you get very high accuracy despite having such a small size of the model. Now, what's next in AI? If we look at the trends, what's happening with AI? We started with chatbots, Q&A, and docs. And over time, this has only gotten more and more complex. With more complicated tasks that you expect AI to do and more complex data you expect it to handle. This all comes down to some level to the prompts that we write for these things, right? You start with a prompt that is maybe 10 lines, 20 lines, but then over time it really becomes many, many pages and becomes almost like a book. And then when you have these agentic workflows with so many different prompts and inference calls, it starts getting pretty complicated. So let's take here, a relatively simplified prompt that's used in an agent. And you can see that this prompt itself is not very maintainable. If you're hired new into a company and you were told somebody wrote this prompt, now you have to change something in this prompt so that we make a very specific change in the behavior of the model. That's not a trivial task because anything you change can have lots of side effects. This is an open free text prompt. So it's not easy to maintain. Unlike, let's say, code, where if you go to code and you add a print statement, only that print statement will be impacted. Nothing else is impacted. So let's dig into this a little bit more. We go to a section of the prompt that provides some security guardrails and some compliance guardrails and makes the model behave in a certain way so that it doesn't do any bad things. Just don't hallucinate, don't make assumptions, and my career depends on it. So it's really trying to enforce the prompt engineer is trying to enforce the model to behave in a certain way. Now, this is fine when you're just doing a pilot or a class project, but in a company setting or enterprise setting, this is not good because the entire security specification is in free text for anybody to see and anybody to change. And it's very sensitive. You change anything anywhere else, it can throw off your guardrails to the model. So definitely this is not secure. If we zoom into a different part of the prompt to look at another aspect, which is the set of requirements and instructions that you're giving it, you're asking it to write a report, a research report with certain structure, using certain language. At that point, you somehow make it work and it works fine with the model. But when you switch in a different model, it stops working because these prompts are very specific to the type of model that you use. So it's not portable. And finally, if you look through this whole thing, there's nothing in it that is efficient because you just write the prompt to make the model do what it does. There's no notion of computational efficiency. So the challenge we have with AI today is making it maintainable, secure, portable, and efficient. And generative computing is really about trying to address some of these challenges. One way to think of it, the idea we're looking at is you have these applications that interact with models through APIs, and they're just sending tokens and receiving tokens. But imagine that instead of the API, we had something called a runtime in between that was more intelligent. And you could provide, instead of a prompt, you can provide structured instructions, almost like a program that specifies what you want the model to do. And the runtime takes care of interpreting that program and prompting the model. So some examples of what these are things like guardrails, requirements, instructions, and generation strategies. So instead of a prompt, imagine you had a program like this that's in a structured way specified your intent. That can really drive this towards efficiency because you can optimize the models to work with these programming abstractions rather than general free-form text and get really optimized models that are small. That is really our philosophy behind Granite 4. You can make these things much more secure because the runtime can do the things around hallucination detection, prompt injection detection. So you don't have all this free text specification of your security constructs. You can actually have the runtime use activated LoRa or other kinds of techniques to make the model behave in a certain way. You can hope to make it portable because now you're not writing prompts for the model. You're writing a generative program which is detached from the model. It's just about what you would like to see happen. And you're letting the runtime decide what the prompts are, and the different models can be handled by the runtime to make sure that the right output happens. And this is much more maintainable because if you come in and you need to add a new requirement, you just add a new line with a requirement. You don't have to mess around with words in a complicated prompt, right? So generative computing aims to make Gen AI and address all those four issues of maintainability, portability, efficiency, and security. This is how we are thinking about Gen AI going forward to have a runtime and models, and Granite is really tuned towards that. We are very excited to launch a new framework called Malia. This is now in open source, which implements some of these concepts. And I will invite all of you to try it out, go read about it. It's on GitHub, github.com, Generative Computing Malia. You can download it on your laptop, play with it, and contribute back to the open source project. And thank you for your time. That's what I had today.
Thank you so much, Amit, and thank you, Sudarshana. I know we are already at the time, so thank you, thank you, everybody. I know we have started the Datathon now officially. I would request all to start working with your team. Now you have all the resources. You heard from all the leaders from IBM also. Hope you all will be equipped with it. You have the submission guidelines. Make sure you keep the link handy with yourself and you can access that for any queries. You know where to submit it, how to submit it. And of course, you have the Discord channel. Use that channel to raise all your queries. With that, Sudarshan, we can wrap this up, right? Okay, great, great. So without taking too much of time now, we will wrap this call. Thank you everyone again, and see you on Discord.